And so we start here. The first one is a double angle formula. Okay, so we have, it really comes from this. I'm just going to write this out. Sine of, you don't have to write this down, I just want to show you where it comes from. Sine of A plus B. Do you remember yesterday how we expanded that? Times cosine of B. Sure, we could go sine of B times cosine of A. Sure, right? It doesn't matter if you switch them around, right? Right? So the question is, what if you have the same angle? What if you double it? Then that becomes A, right? And that becomes A, and that becomes A, right? And notice how these two are the same things. So you end up with 2 of the sine A cosine of A. So if you have a double angle, it becomes that. So now that we have that formula, the sum and difference, we can come up with all sorts of other formulas as well. And we're going to write those formulas down for you right now. Your double angle formula, sine of twice the angle value is 2 times the sine of A times the cosine of A. I will not generate all the rest for you, but if we expanded the cosine one, we actually come up with 3 options. You get to choose one. You don't use all 3. You choose one. So the cosine of twice an angle is equal to 2 cosine squared of A minus 1. Were you writing in the wrong box? Sorry. And cosine squared of A minus sine squared of A. That's another one you could use. Or you could choose to use my favorite that I wrote last, 1 minus 2 sine squared of A. So that's the one that I like to use the most. And tangent of a double angle, tangent of 2A is equal to, on the top we get 2 tangent of A divided by 1 minus tangent squared of A. All right. So this is the kind of problem we get on the test, and this is where people start to write IDK. All right. This one's worth a fair amount of points, and it doesn't have to be that difficult, but we find a way to struggle with it. It simply says that cosecant is 2. It tells us that the angle X is in the second quadrant, and we currently have a single angle. It wants us to produce the value of the double angle formulas. That's what it wants. Okay? That's what it wants. So I always start with just this. Sine of 2x is going to be 2 times the sine of x times the cosine of x. That's my double angle. Can somebody tell me if cosecant is 2, what else do you know? If cosecant is 2, then sine is a half. Everybody clear that if cosecant's 2, sine's a half? So cosecant and sine are reciprocals, so you take the reciprocal of 2. Everybody okay with that? All right. Now, if we know that sine is a half, we don't necessarily know what cosine is. But we learned that if you do know sine, you're able to find cosine. What can you do to find cosine? What can you do to find cosine? Very good. Sine squared of x plus cosine squared of x is equal to 1. You remember that formula? Yeah. So we can use that to find the cosine value. We've done that before, haven't we? So actually, you haven't learned much new. We have this new formula. You already knew that that was 1/2, and now you need to use this formula. What is sine squared? What do you get if you square a half? So 1/4 plus cosine squared of x is equal to 1. What do I do now? Subtract the 1. We get cosine squared of x is equal to 3/4. Then, cosine of x is equal to the root of 3 over 2 when you take the square root of both sides. And it is plus or minus. Can somebody tell me if it's going to be positive root of 3 over 2 or negative root of 3 over 2? Why is it negative? Second quadrant, cosine is negative. If you could do that, the rest is easy. So just remember, we knew that that was 1/2. We just used sine squared plus cosine squared to get that. The rest is easy now. What's 2 times a half? 1 times negative root of 3 over 2 is negative root of 3 over 2. We're done with sine of 2x. We move on to cosine. You can use any one of these 3 formulas. I'm going to choose to use the bottom one. 1 minus 2 times sine squared. What do you get when you square sine? If we square a half, we get a 4th. Notice that it's right here we squared sine. That's why I like to use sine, is because it's often already used over here. So we see it's a 4th. What's 2 times a 4th? 1/2. And what's 1 minus a half? 1/2. And now I like to do the tangent formula, but I don't actually use the tangent formula. I have an easier option. Tangent of a double angle is equal to that, but it's also just equal to sine of the double angle divided by cosine of the double angle. So once you find each double angle, you can simply just divide them. And so tangent of 2x is going to be sine of the double angle, which is negative root of 3 over 2, divided by 1/2. Multiplied by the reciprocal, and I get negative root of 3. Not too bad. Good. All right, half angle is on Monday. Second hour is missing their class due to wall of inspiration. So on Monday, they're going to have to see a little bit more of stuff. So I'm trying to strategically plan. So the second part we want to do today is the lowering powers. Lowering powers. So I'll show you one example. We just wrote down that cosine of a double angle is equal to 1 minus 2 sine squared. That is a formula that we know, okay? And so we can actually solve for sine squared by subtracting 1. Cosine of 2a minus 1 is equal to negative 2 sine squared of x. Then you can divide by negative 2, and when you do, you end up with a positive 1, a minus cosine of 2a, all over 2 is equal to sine squared of x. So this is what we call a power reducing formula, and it's power reducing because it goes from a squared down to a single power. Now, you would be right to ask, why would you ever use that in real life? You never, ever, ever would, okay? But the class is not called how to use math in real life. It's called pre-calculus. If you want to be able to do calculus, especially calculus 2, this is a formula that gets used often. It's super important. We like this. We're going to make use of it. You have to see it now so that you can use it later. So this skill that you're going to learn, this is one that will be locked in and ready to go in case you ever move on to take that type of a course. So lowering powers formulas. Sine squared of x is equal to, turns out to be 1 minus cosine of 2x over 2. And I'm not going to take the time to show all the formulas or to prove them all to you. I'm just going to write them down. I'm assuming that once you've seen one, you trust that I can show you all of them. The cosine squared is 1 plus cosine of 2x all over 2. And so the tangent squared happens to be 1 minus cosine of 2x divided by 1 plus cosine of 2x. And there we have our three formulas. Everybody okay there? Okay, before we do these two problems then, I want you to move to your very back page here. I want you to see where we're living today. So today we are working with our double angle formulas. We're doing that box. You can see that we listed that one and that one. And then I said cosine of a double angle, you could choose any one of those three. So on the test, please do not do the problem 3 times. Choose one. See what I'm saying? And I like to use the last one. That's me. I just wrote down all the power reducing formulas. Those are 3 that I just wrote down. And on Monday, we will do the half angle. We don't get to the sum to product and product to sum, which is unfortunate because they're actually the easiest ones. But one of the challenges, we're running out of time, and those don't get used as much. These get used more. Okay. Very good? Okay. So we're going to do 2 power reducing formulas. Okay. All right. There's only so many power reductions that you have to do and be capable of. The most important power reductions that you want to be able to do are sine squared times cosine squared, sine to the 4th, and cosine to the 4th. So for that reason, you will have those 3 problems on your assignment. We're doing 2 together in class. So the idea is that you'll do them on your assignment, and if you get stuck, you can look back at here to follow through. See what I'm saying? Now, I could change this up. I could give you a tougher problem. We could do sine to the 8th. But the fact is, I've just learned over time, it's not that necessary moving forward. Do you get my point? But those 3 are very important. So I do 2 of them for you. You see a 3rd one then on your assignment. And your test, I will be asking you to perform one of the 3. Got it? Not going to tell you which one, but of those 3, you're going to do one on the test. Okay. So it says rewrite the following expressions in terms of first power of cosine. What does that mean for us? What it means is that all of these, if you notice, they all have cosine in them, don't they? So anytime you reduce powers, it always ends up being that it's just cosine, and it ends up that it's cosine of the first power. Notice we got the double angle thing going on, which is a little bit awkward, but we'll work through it. And so I do sine squared times cosine squared. So the first thing I'm going to do is I'm just going to, instead of sine squared, I'm going to write 1 minus cosine of 2x over 2. And instead of cosine squared, I'm going to write 1 plus cosine of 2x all over 2. Everybody okay with my first step? Okay, let's multiply the denominators. What are you going to get? 4. That was easy. Now, let's multiply the numerators. What do you notice about the numerators? They are, so the C, they are conjugates. And because they are conjugates, the middle will cancel. We all see that? So I'm trying to, I used to write it out, but now I'm trying to help us just kind of see that to save us time. 1 times 1 is 1 minus, and then this becomes cosine squared of 2x. You don't do anything to the angle. You don't take like 2x times 2x. It's not 4x squared in the middle there. You just square the operation. Okay? So let's look back at the directions and see what we've achieved. Rewrite first power cosine. Do we have cosine? Yay! No more sine is there, right? That's a good deal. But we don't have first power anymore, do we? So it became second power. So we need to insert a formula there. Well, I have a formula for cosine squared of x, but not cosine squared of 2x, do I? So I need to make another formula. And this is the last kind of challenging thing you have to see, and it's not that bad, but follow my lead here, okay? When I went from here to here, what happened to the angle as it went from there to there? The angle doubled. Everybody agree? So if I have cosine squared of 2x, what's going to happen to the angle then? It's going to 4x. It will just double. So cosine squared of 2x is simply this. It's just the angle doubled. That's what happens. So we have another formula. Suppose it was cosine squared of 5x. Then it would be 1 plus cosine of 10x over 2. It's just, you just double the angle. Everybody see that? All right. So now I have something to plug in. I plug in this for this. 1 minus 1 plus cosine of 4x over 2. All over 4. Can I leave my answer like that? Why? What's wrong with that expression? Why? Because it's a complex fraction, and you're not allowed to leave a fraction within a fraction. So Trinity says, let's deal with that by creating a common denominator. We're going to put a 2 over 2 here. And I'm going to make sure I distribute the subtraction sign to both the 1 and the cosine of 4x. 2 minus 1, 1. And then is it going to be plus cosine of 4x or minus cosine of 4x? Minus cosine of 4x. What is that denominator now? 2 and over 4 over 1. Multiply by the, and so I get 1 minus cosine of 4x all over 8. That's the answer. I did have a class one time. They didn't want to write it like that. They wanted to try as 1/8 minus cosine of 4x over 8. They like to have 2 parts. That would be the same. I don't care how you write it. I just want the complex fraction gone. First power of cosine turned out to be a 4x instead of a 2x in the end. See that? So you're going to have that same type of problem on your assignment. And the last one we do for today is sine to the 4th of x. Let's try to think about this together. Anybody know what I should do first to try to work with this? And I'm going to tell you, I do not start by substituting this in. Anybody know what the first step is? Hint, I'm going to rewrite this as something sine squared times sine squared. Because I know what sine squared is. I don't know what sine of the 4th is, but I know what sine squared is. So now I can take that and say 1 minus cosine of 2x over 2 times 1 minus cosine of 2x over 2. So these are not conjugates, are they? So the middle's not going to disappear on us this time. And that's okay. 1 times 1 is 1 minus, not 4 cosine, but there's 2 cosine of 2x's plus cosine squared of 2x all over 4. Okay, so that was our first step, and it looks like in this situation, it looks like we've got all cosines now, don't we? And we have a cosine to the first power here, but we don't have a cosine to the first power there. So this thing is the one thing we've got to kind of work with now, okay? So what do we want to insert for cosine squared of 2x? 1 plus cosine of 4x over 2 all over 4. Right, now we're sitting at the complex fraction point. So I'm going to write these all. I'm going to actually take time to write this out. 2 over 2 minus 4 cosine of 2x over 2 plus 1 plus cosine of 4x over 2 all over 4. There we go. So now I've got common denominators. Is there anything here that you can combine together? Any like terms? The 2 and the 1 make 3. Because it's a positive 2 and a positive 1. And then it's a negative 4 cosine of 2x. And it's a positive cosine of 4x. If the angles are not the same, you can't combine them together. Okay? We would need a different kind of formula for that. All over what? 2 all over 4 over 1. Multiply by reciprocal, and I get 3 minus 4 cosine of 2x plus cosine of 4x all over 8. Okay, good job. Take out your homework. I will tell you that Monday's lesson is easier. Not that that's super hard, but that does give people a little bit of a challenge. And let me pull up the assignment here. Okay, so the very first assignment, you have sine is 5/13, and you have cosine is 4/5. I would actually encourage you to do problems 1 and 3 first, and then I would do 2 last. And just to be clear, for problem 2, are you given sine or cosine? No. Does anybody know what formula you use if they give you tangent? Do you remember that? You don't use sine squared plus cosine squared is equal to 1. Do you remember what you use? I heard it. Yeah, very good. So I'm just going to make that note for you. Here you can use sine squared of x plus cosine squared of x is equal to 1. Here you can use 1 plus tangent squared of x is equal to secant squared of x. And once you get secant, you then know cosine, right? You know cosine. And then you can use that to find sine then. So you've got that option. And then for this one, obviously, you can use the 1 plus, the sine squared of x plus cosine squared of x is equal to 1. Okay, so you can do those. So 3 problems like we did for the first example, and then if you flip it over, I'm just going to do 1 problem with you. Does that look like something you've seen before? Isn't 1 minus 2 sine squared of an angle the same as cosine of twice the angle? Doesn't it look like that formula? So in these 4 here, you want to recognize the formula. This one looks like that, right? So to simplify this, I just read it as cosine of twice the angle. What would be twice that angle? 2 pi over 7. Good job, Colby. So you can recognize which formula it matches up to, so those should be quick, okay? And then I told you that we did this one together in class, didn't we? And we did this one together in class. So this one is new. It should follow very similarly. And on the test, I will be asking you simply one of those 3, okay? This one's optional if you want to try a cosine to the 6. I think it's pretty cool, but you might not. All right? So, 1 assignment left after today. You have Tuesday and Wednesday to be able to ask questions, and you should be able to have a decent amount of time on Monday. We won't have that long of assignment. However, can I please encourage you that if you have, as you work through your assignments this weekend, if you get time, might not be bad to try that study guide and try some of the problems that you feel like you know how to do. Because I do worry that come time, and actually you guys are very fortunate. We've got, how many people in this class right now? Like 12? Okay? So if they wouldn't have cut the classes up into 3 groups, I would worry that we wouldn't get all the questions asked or answered on Monday or on Tuesday and Wednesday. So that's how it goes with calculus usually, is that there's 30 of them in there, and people leave, they're like, well, at least I got 1 out of my 4 questions answered, so there you go. A couple minutes. Nice job today.